Greetings, math fans. All right, so this is the extra problem we have for day 3. So the problem is f of x equals 2 over the cube root of 9 minus x squared. All right, so we want to graph this. We want to find out a few things too. We want to find out the domain and the range of this function. The domain is actually pretty easy, right? It's basically the acceptable values of x that doesn't make it undefined, the function undefined. Okay, and that's pretty much, you don't have to worry about the cube root because it could be negative, so that's okay. It's just the denominator cannot be 0. So we're going to do 9 minus x squared equals 0, so x squared equals 9, and so x equals plus or minus 3. All right, so that's kind of nice. So it's my domain is going to be negative infinity to negative 3, union negative 3 to 3, union 3 to infinity, because it doesn't include those values, right? And another thing we kind of pull off of this too is we can pull off the vertical asymptotes with that. That's kind of nice because we need to graph it. So, and those are going to be, and don't forget, it's x equals negative 3 and x equals 3. Okay, you need to have that x equals. It's important. Don't give me a 3 and a negative 3. All right, so I need to find out the range. Well, I'll tell you, math fans, the range is actually a little bit more challenging with this problem. Okay, of course, this is acceptable values of y. And it's kind of, again, it's a difficult problem. I think a good idea would be to actually graph it and then come up with the range after I graph it. Okay, so, a couple things I can do. One thing is I can come up with a horizontal asymptote. And you guys remember that if the degree of the denominator is greater than the degree of the numerator, it's automatically what? It's automatically y equals 0. Okay, so that's kind of nice. So we've got vertical and horizontal asymptotes. What else can we kind of pull off of this? Well, how about that it's an even, odd, or neither one of those function? Well, it's got the cube root, but of course it's got the x squared, which we've worked with already. And if it's x squared, let's just plug a negative 1 and a positive 1, right? If I plug a negative or a positive 1, I get negative 1 or 1 squared is 1, so 9 minus 1 is 8, so it's the cube root of 8 is 2, and 2 over 2 is 1. So it's 1 for f of negative 1 and f of positive 1 gives me the same value. We pretty much can say it's an even function, right? Well, that's kind of helpful. And the reason it's kind of helpful is because when we try to graph it, it just helps us even see what the graph looks like. So it's an even function, which means it's symmetric about the y-axis. Okay, that's kind of nice. All right, so let's graph it now. All right, so let's put our asymptotes in here. We have x equals 3 and x equals negative 3. Okay, and we'll have y equals 0. Let's figure out what's going on in the middle in between the two asymptotes. Well, it's got to be something symmetric. And let's plug a point in. Since it's symmetric, it's got to be someplace, there has to be a point on the y-axis if it's symmetric, right? So let's kind of think about this. What if I plug in a point? Let's check out what's going on the y-axis. F of 0, and so we get 2 over the cube root of 9 minus 0, so 9. All right, and actually, just to kind of help plot it, if I do 2 over the cube root of 9, right, I get about 0.96, just to kind of help me graph it. So if I plot that point, it's right about there. Okay, and I want you guys to understand there are no zeros or roots in this problem because there's no way f of x can be 0, right? I mean, you can't make the denominator 0, make it 0 because it would be undefined. But there's basically no variable in the numerator, so there's no way this could be, you could have any roots. So if there are no roots, that means it's not going to cross what? It won't cross the x-axis. So that means it's got to go like this. And remember, guys, that's why you draw an asymptote, or especially a vertical asymptote, and it doesn't cross a vertical asymptote. It could cross a horizontal, but it always approaches it. It always gets closer and closer and closer to it. So let's think logically. If I pick the value of, going back to our original function, you can't pick 3, but let's say I pick 2.99999. Well, 9 minus 2.999 squared is 9 minus almost 9, so it's some really small number. The cube root still really small. 2 over some really small number is really big. That's why the x value gets closer to that 3, or the negative 3, and the y gets really huge because the 9 minus that almost 9 is, and then 2 over that really small number is a big number. Okay, so that's why it's approaching those asymptotes going in the positive direction. Again, it can't go the negative direction because it would cross the x-axis, and you can't have that because there are no roots. All right, so now what I want you guys to do is I want you to kind of think, where is it going to cross now? I'm guessing it's either going to be here and here, or here and here. All right, because it's got to be symmetric about the y-axis. So it's either the top 2 x's or it's the bottom 2 x's. So let's think about that. Well, probably the best way to figure that out is, plug in a couple points. Let's do that. So let's plug in -4 and 4. Well, they should be the same, shouldn't they? Because it's an even function, and they are, right? So if I do in the denominator, and I'm not even necessarily concerned about what the value is. I'm concerned with, are they positive or negative? Because if it's positive, they're up on top on the in the first and second quadrant, and if it's negative, they're in the third and fourth quadrant. So if I put, let's just put, doesn't matter, -4 in there. -4 squared is 16. 9 minus 16 is -7. So right off the bat, I know this is negative. So I'm just going to write negative. I'm not even going to put a point here because I'm not concerned about that. So if it's negative, that means my graph is going to look like this. And notice the symmetry, guys. Still symmetric about the y-axis. Okay? So let's go back to the domain and the range. We already have the domain. Let's go back to the range. And we can look at the graph now. Well, obviously, it's going to be something. So let's write this out here. The range is going to be between -infinity and 0, right? Not including 0, union. And, well, it doesn't appear that it's in this area here, right? So, in fact, it starts right here. So what we're going to do is we're going to say union, and we're including that value because it's a point, 2 over the cube root of 9, comma, positive infinity. That's my range. Okay? So that's it, math fans. That's the graph. That's the domain and the range. It's really helpful to kind of apply all these different techniques because when you guys are taking the AP exam, there's going to be a portion on there that is going to be non-calculator. And they may ask you different things about graphs. And we're going to cover a lot in the next chapter with limits, but you're going to have to be able to sketch a graph based on some function that they give you. So you have to use your knowledge of domain, range, asymptotes, even and odd functions, and it's just going to come in really handy. So hopefully this kind of was a really good example of just kind of applying all that and kind of coming up with the range at the end. Based on, the sketch of the graph. All right? That's it, math fans. Have an outstanding day. Adios. Goodbye.